The topic is visualization of R and S configuration. You see, this is a Fischer projection formula, and in this Fischer projection formula, say these are hypothetical groups 1, 2, 3, 4, and it is expected on the basis of this formula, Fischer projection formula, you could able to visualize the molecule and identify whether the molecule is having R configuration or S configuration. Basically, R and S configuration categorizes the chiral molecule, the chiral carbon especially, into two categories, either S or R. S stands for sinister, R stands for rectus. S means left hand side towards, and R stand for towards right hand side. Now just see that this say this is one example, and I have prepared one model, and this is a Fischer projection, so we have to see the model like this. And to make it more simpler, I just gave the number instead of any groups or functional groups. So for simplicity, what we will do is that we will consider this white as number 4, then we will consider red as number 1, green number 2, and yellow number 3. So white means 4, red means first 1, green means 2, yellow means 3. So when it is represented like this in Fischer projection, it means that this fourth group is, we have to see the molecule like this, and this fourth group is here, second group is which is green, you are seeing that is on the top, and towards left, that is red is 1 and yellow is 3. So if you see the number, if you count this 1, 2, 3, just tilt a molecule a little bit like this. So this is actually what is expected in RS configuration. The lowest priority group, this white, should be below the plane, and these 3 groups are pointing towards you. Now if you count it, red is 1, green is 2, and yellow is 3. If you see the rotation, it is clockwise rotation, so it is towards right hand side rotation, and therefore this is having R configuration. So this is example of R configuration. So this is R configuration 1, 2, 3. So right side clockwise rotation, so it is R configuration. And is it possible to make it left side? Yes, no, because it is this red is this side and green and yellow, so I have to break like these bonds to make it happen. Or simple thing is that I have to take mirror image of this. Now if you see the mirror image, and if you just put it like this, you can understand this is 1 red, green is 2, yellow is 3. So this is S configuration. This is S. This white group is away from you, and this is 1, 2, 3. So this is S or sinister or toward left, and this is R, rectus or towards right, 1, 2, 3. So these are two enantiomers of each other. If the projection formula of the same molecule is shown like this, you see first what is the difference. The difference is that the fourth group is here above in the Fischer projection, second is below, and here it is written 1 and here it is 3. These two molecules are not different, they have just different orientation in 3 dimension. So what is that? Let's understand. This is first, so first what I said, that like this it is. Okay, so this is 1, 2, 3, this is R. But here in this what is shown that R is above. So if I want to make this white group above, what I have to do, I have to change like this, I have to rotate like this. Now it's okay. This is below the plane according to Fischer projection. This is below the plane white, and it is above. So this is representing the second formula, Fischer projection formula. But you see the changes took place in the position of the groups. When I made like this, the red is toward my right side, so it is here written 1, then green 2nd, and yellow 3. So when I made like this kind of orientation, Fischer projection, and looking this molecule again, whether it is changing its RNS configuration, you see 1, 2, 3. So again it is same clockwise toward right side rotating. So configuration has not changed, but position of the groups, if you see, changed. 4 when it is coming on the top, the second is going to bottom, then third and first, they are changing position. Why it is happening? Because the molecule, if you see in the first example, we are seeing like this. The hydrogen, the fourth group, is below, and in the second example we have to make this above this position, and we have to keep in the mind that both the groups, the hydrogen is below the plane. So possibility is that we should rotate like this, and while rotating, just see this, red is coming this side, yellow is coming this side, like this. Now like this, but their R and S is not changing. Still it is 1, 2, 3, means it is R configuration. Just looking how we are looking, it is changed. Try to understand what happened if the fourth group, the least priority group, is toward left side of Fischer projection. So this is our first molecule. So in case of this first molecule, if you see, the fourth group was at the bottom, away from you, like this. Okay, so this is R configuration. This is Fischer projection. This is how you look this configuration. It was R. Then what happened in this molecule? We have to keep this R toward left side, so like this. But if you see, this is not actually a representation of Fischer projection, because in Fischer projection, this line, horizontal line, represent that the groups are pointing towards you, or they are above the plane of the paper. So these two are below the plane, this green and white. What you have to do is that you have to change the orientation like this. Now it is Fischer projection, left side, least priority fourth group. And what you are seeing, this right hand side, the green color, and this is below red, and yellow is above. So you can write like this, the fourth here, green, yellow, sorry, this red was 1, so you will write here 1, this green 2, so it is 2, yellow above, it is 3. So this is actually a representation of the same molecule when this least priority group is left side on the Fischer projection formula. What you have to notice is that if you see what is happening, the fourth group, when it position changed toward this side, one position and other group's position also has been changed. Here it was 1 toward left side, and you are seeing here at the below 2 right side, here is 3. 2 was above here and 2 toward right side. 3 is above here, and you are seeing 3 here right side. So why this happened? Because how the molecule is seen in the Fischer projection. Because of that, here we saw like this, the least priority group is below, and here the least priority group is left side, but this is not proper, so we change like this. Now this is what you are seeing, that fourth group is here, then first below, right side second, and third yellow top side, which is actually these two are the below the plane, this yellow and red. And if you want to know configuration of this, again you have to tilt like this so that the least priority group should be below the plane. If you see, it is 1, red is 1, green is 2, yellow is 3, so it is again R configuration, because molecule is not changed, just perspective how we are looking it is changed. So that does not mean the RS configuration will going to change, it will be again R. What happened when fourth group is toward right side? This represent that they are pointing toward you. So what we have to do again, like this, the fourth group to a right side, but it should be pointing toward you, so like this orientation. Now in this orientation, what you are saying, this fourth group is right hand side, and this groups 1, this is 2, this is 3. So orientation, here we have to write like this, 1 is above toward left side 2, and bottom is 3. Okay, so this is Fischer projection. Now we will see RS configuration. So we have to put this white group, this priority group, at the back. So we are doing like this, it is going at the back, and what you are saying again is 1, 2, and 3, the highest priority, right, then green, then yellow. So 1, 2, 3, this is again R configuration, because molecule has not changed, again it is R configuration. So in this example, what we saw in Fischer projection, whether the molecule present in orientation, whatever it may be, the R configuration or S configuration does not change. This is related with R isomer, one isomer, enantiomers one pair, and if you take another mirror image of the same of enantiomer, you will see S configuration in all the cases. So this was related with visualization of R and S configuration with model in case of Fischer projection.